Are you a small team with minimum budget not being able to spend on enterprise grade applications, but at the same time you want to gain some really useful insights about your system? This talk is just for you. I know that distributed systems are very complex and tracing issues in a distributed system is very difficult. And at the same time, enterprise solutions, although very helpful, are very expensive, especially for small teams. So in this talk, my objective is going to be how to build minimum observability stack in Kubernetes, keeping the costs low while also gaining some useful insights about your system, and finally avoiding some obvious pitfalls that you can run into while designing some of these systems. So let's get started. Now, before getting into the actual tools and how to set up the actual stack, I would like to discuss what I call the 4 pillars of observability. First is logging. Logging is the process of tracking specific events in your application. Now, these help you answer questions like what is happening in my system? Second, we have metrics. Metrics is nothing but numerical measurements for performance of your system over time. They really help you quantifying the performance of your system. So they can help you answering questions like, how is my system behaving over time? The third is tracing. Now, tracing is the process of looking at your system, looking at the flow of requests in your system. Now, if you're someone who is aiming for P99 performance or really high performance system, tracing will help you identifying the specific bottlenecks in your applications so that you can target that specific area, reduce the latency, and increase the overall performance. Now, dashboard is nothing but visual representation of all the data that you're aggregating in all these pillars and showing it in one particular dashboard so that you can act on that information as quickly as possible. So they help you answer questions like how quickly can we act upon identifying an issue. Now, for all these pillars, I have identified one of the most popular tools that are available open source, starting with logging. Fluentd is one of the most popular log aggregator found in the open source community. For monitoring, we have Prometheus. Prometheus is arguably one of the most used components in a Kubernetes clusters for aggregating your metrics data. Coming to tracing, we have a tool called Jaeger. I could also find other tools like OpenTelemetry, but Jaeger is one of the most easy to set up, especially for smaller teams. And finally, coming to dashboards, Grafana is arguably one of the most used open source tools for setting up dashboards for your observability stack. Now we are going to look at how to set up each and every single one of these components in your stack with the minimum amount of steps. Starting with logging, you can, if you have a Kubernetes cluster, you can directly run this command kubectl apply. This will pull the YAML file that is written by the Fluentd team itself. This will make sure that your cluster is always running the latest version of the Fluentd components. Coming back to Helm, if you're someone who's using Helm inside your cluster, you can also run this Helm command. This will pull the Helm charts directly from the Helm repository that Fluentd maintains. It will install it in your cluster. Once you have the component running, you can have your applications push your logs directly to this aggregator where it exposes the port 24224. And the best practice I would recommend is to use JSON log so that it's easier for parsing for Fluentd. Next up, we have metrics. Now, if you're someone who uses Helm, you can run this command. This pulls the Prometheus components directly from the Helm charts, Helm repository, and installs it directly in your Kubernetes clusters. Once you have that running, you can use your applications you can use the client libraries available in different programming languages like Go, Java, Python, C++, and directly export your data into the metrics endpoint. Finally, you would also have to do one more step. You will have to specify the targets for your application. So in this example, I'm overriding the values.yaml file into my Helm config and specifying where exactly my application lies within the cluster. So in my example, this is in my app service, which is exposing a port 8080. In your case, it may be the DNS of your application itself. Coming to tracing, you can either install it via directly by the Kubernetes YAML file that Jaeger provides, or you can also use Helm as the other steps that we have seen so far. Once you do that, you will have a Jaeger agent running inside your Kubernetes cluster. Once you have that, you can use the client libraries available in different programming languages, export the data directly to the Jaeger's collector endpoint. Now, this is an example from the Python library, wherein I'm specifying the host name for my Jaeger agent. This is nothing but the service name inside the Kubernetes cluster. And this is usually the port where Jaeger exposes its particular exported endpoint, which is 6831. In your case, if it is a different one, you can use that one. Now, finally, we have the dashboard wherein we provide a visual representation for the data that we have collected so far. So you can either get your Grafana components running directly via the Kubernetes YAML file or the Helm, as we have seen so far. Once you have that, you need to specify data sources for your Grafana component. Now, data sources may be the Prometheus, which is the metrics, the Jaeger, which is nothing but the tracing data that you've collected, and also the logs that you're collecting from the fluentd. So in this example, I'm overriding the values.yaml file inside the Helm config and specifying the data source for my Prometheus component. So this will make sure that whatever data that I'm collecting inside the Prometheus component is available in my dashboard on the Grafana component. Now, once you have this observability stack set up, there are some of the best practices and some of the lessons, some of the obvious pitfalls that I would want you to avoid. First one is avoid alert fatigue. Now, I've seen this with multiple teams setting up alert for every single issues that pop up in their applications. Once you do that, you get so many alerts that soon it's no longer a signal, but it becomes noise. So you are more likely to miss some useful information. Now, this exactly happened in my previous company, wherein we set up alerts for every single issues, and soon enough, the mailbox of our entire team was so full that we stopped receiving alerts altogether, and we were more likely to miss some useful alert. So I want you to be very specific on what issues that you want to track and set up alerts only for those issues. And for other issues, you can get away with setting up logging inside your fluentd component. Now, the second pitfall that I would want you to avoid is don't oversample metrics. Now, what that means is control the frequency of data that you're sending to the metrics endpoint. Now, what this means is do not send data too frequent, for example, every second. Now, this also depends on the type of systems that you are supporting, but having a good balance is always better, because if you're sending data too often, it soon becomes noise rather than signal. So you're more likely to miss some useful information. So it's better to send data at a frequent rate rather than at an acceptable rate rather than very frequent. So something like 1 minute is a good balance. Finally, dashboard hygiene is one of the biggest mistakes that SRE engineers often make. What they think is the more data we provide on the dashboard, the better insights that we can extract from it. That is actually far from the truth, because the more data that you provide, the more noise you create. So more likely you are to miss some useful information. So what I would recommend is, based on the individual that you're creating the dashboard for, keep the data that you're providing very focused for that individual. So for example, if you're providing the dashboard for a manager, have data that provides a 10,000 feet overview of the system rather than providing very specific data inside the application. So you keep the noise outside and you provide more signals for that particular individual. Similarly, if you're creating a dashboard for a developer, I would want you to provide data that's giving a more deeper look into the application itself, like something like the logging aggregator would be a good use for developers. So based on the individual that you're creating the dashboard for, keep the data very focused for that particular individual so that you don't create more noise and you provide some useful insights. Now, quickly giving a summary of what we have discussed so far. We discussed the 4 pillars of observability, starting with logging. This helps you answer questions like what is happening in my system. so that I can identify any issues that are going on, looking at the logs itself. Metrics helps you answer questions like, how can I quantify the performance of my system? Coming to tracing helps you answer questions like, where is the bottleneck in my system, so that I can target a specific area and increase the overall performance of my system. And dashboards are nothing but providing a visual representation of the data that you have created so that you can identify issues in a particular area and you can act on that quickly as soon as possible. Now, I hope that this talk was helpful, that it provided you with the minimum amount of steps for getting an observability stack running in your system. And if you want to discuss more on this topic, and this is my LinkedIn, this is my GitHub, and this is my blog where I post similar software engineering content that I learn on a day-by-day basis. Thank you.